Hello and welcome to Prototype and See, a brand new podcast for designers, engineers and innovators all about the product development journey. My name's James Murphy, co-founder of HLH, one of the world's leading manufacturers of prototypes and low-volume production parts. I've been in this industry for nearly 20 years, but I feel there's still a great deal about our customers that I don't yet understand. So, in Prototype and See, I'm going to be sitting down with some of the world's most innovative companies, talking to designers and engineers, all about the successes and failures, the ups and downs of bringing new products to market. So, welcome, Michael Norcia. Is that?
Yeah, you got it. People rarely do.
All right.
You got it.
Yeah. Where's that name from?
It's an Italian last name.
Is it?
Yeah.
Okay. All right. Welcome. Thank you for coming on and talking to us. So you're from Pyka, which is a autonomous aircraft. Are you still a startup?
Yeah, I would say so.
Not anymore. You would say so.
Yeah.
Okay, and it's quite a iconic startup story as far as I understand it. So the company started in your parents' garage, I believe.
Yep.
Could you tell us a little bit about that?
Yeah, absolutely. So I've been just very deeply passionate about aviation since I was a little kid. So this was definitely not the first large aircraft to be made in my parents' living room or garage or backyard.
Yeah.
I'd been working at a couple different electric airplane companies in the Bay. Worked at Joby for a very brief period, and then worked at Wisk and Kitty Hawk on their different eVTOL aircraft. So all vertical takeoff and landing air taxis. And left those companies for a variety of reasons to start Pyka. And we were bootstrapping the company for the first 9 or so months. No cheaper place to build an airplane than your parents' backyard. So we set up shop there. It was awesome.
Okay. And was the backyard big enough for you to test it too, or did you have to take it elsewhere to do that?
Oh, definitely took it elsewhere. Yeah, the first plane we built was 400 pounds and I think a 26-foot wingspan. So it took up a significant portion of the backyard. There's actually like a little soccer field behind my parents' house, and we would do some taxi testing back there, which was absurd looking. Like imagine a 400-pound UAV taxi testing in a residential field.
Yeah.
But
how were the police and the authorities with that? Were they okay with that?
Yeah, I mean, I don't think we encountered anyone. My parents live right next to Stanford University, so there was, I think, there's some tolerance for very bizarre, technical creations,
Yeah.
roaming around.
Good to hear.
Yeah.
Okay, so that was where the company started. Tell us a little bit about where you are today.
Yeah. So that was about 6.5 years ago. Where we are today, we have two different products. Broadly speaking, we focus on large autonomous electric aircraft, really for industrial use cases right now. We set out to be the first company to commercialize that technology. There have been large drones, but basically exclusively in the military space. So not designed to be particularly easy to use, obviously not designed to be affordable in any way. So we set out to be the first to commercialize that, and I'd say we've very much achieved that at this point. So we are shipping both products to customers at this point. The spray plane has been around for a while longer than the cargo plane. So sorry, I forgot to mention we have these two different products. One is focused on aerial application or crop dusting, and the other is a variant of that same aircraft, which is focused on logistics and cargo delivery. We're operating in, I think, 4 or 5 different countries at this point around the U.S. or around the world, and starting to ramp up production, which is exciting, but also obviously quite challenging.
Yeah. So crop dusting. I mean, we're in the UK. It's quite a small country compared to you guys. So it's quite difficult for us to get our head around crop dusting, really. So how big are these farms that
need dusting? Like
Yeah.
enormous?
Yeah, some of them are enormous. So in Brazil, for example, the largest single, it's not really a farm, it's more a collection of farms owned by one company, has more land area than I think the state of Rhode Island.
Right.
Here in the U.S. Rhode Island's not a very big state, but still, it's huge.
Yeah.
So yes,
Sounds big to
a
me.
lot of them are big. A lot of the customers we work with have, in the range of 10 to 20,000 hectares of farmland. That's sort of more in
Hmm.
the banana space. And then yeah, in Brazil, it can be an order of magnitude larger than that.
Okay. And why is your solution a good one?
Yeah, good question. So there's basically you need to spray crops, unfortunately, to grow large quantities of food, just to protect them from a variety of pests. Depending on the crop, you might need to spray it a few times a season, all the way up to literally like 60 times over the course of the year. Um, and a lot of the times you have to do it by air. A lot of
Hmm.
crops grow in such a way that you
Is
can't
that
actually.
just due to the size of the fields, or are
It
there
can be,
other reasons?
yeah, it can be both. So as the field gets enormous, it becomes actually very efficient to do it with an aircraft. But also, if the crop gets very tall, it becomes impractical to drive a ground sprayer
Right.
through the crop.
Yeah. Okay. Yeah.
Yep.
Okay.
So you have to spray it by air a lot of the times. And when you do spray it by air using existing technology, which is a very large aircraft, actually, they're 10,000 pound gross weight single engine turboprop planes, basically. Um, it's
Hmm.
really difficult to actually get the chemical to go exactly where you want. So you end up
Right.
with a non-trivial amount of chemical drifting off of the crop.
Okay.
That's
And
very
why is that?
well. So you're spraying a very fine mist of chemical, and so
Uh-huh.
that mist interacts with different parts of the sort of aerodynamics of the aircraft. It gets kind of like sucked up into the wingtip vortices to some degree. It also goes into the propeller wash and starts to swirl. Um, and so those effects end up leading to some of it kind of just moving upwards rather than down into the crop.
Okay.
A
Okay.
whole bunch of reasons. So basically, we're able to, long story short, significantly mitigate that risk of chemical drift. We're able to
Uh-huh.
spray at night, which is a really big advantage. The conditions for spraying are often much better at night than during the day.
Hmm.
Um,
Hmm.
the vehicle is far less expensive per hour to operate. Um, you know, uh,
Just
uh,
because it's unmanned.
yeah, and because it's electric, both of those are huge wins. And then the last reason is crop spraying by air is incredibly dangerous. It's like the second most deadly job in the United States. So
Right.
moving the operator from the aircraft to the ground is a really
Yeah.
big advantage.
Yeah. Yeah. Okay. And is that kind of dissipation of the spray, the chemical, is that one of the reasons that you went with a fixed wing design rather than the more, I guess,
Like
what
a
people
multi-rotor.
associate with unmanned
Yeah,
vehicles like the Eve, what, how do you
eVTOL,
say
yeah,
it?
or
Yeah,
drone.
eVTOL, yeah, yeah. The
Yeah,
drone style, yeah, with the
yeah,
four
yeah.
propellers, yeah.
Yeah, that's definitely part of the reason. It's a lot easier to kind of very precisely place the chemical with our aircraft. It doesn't really suffer from the issues I mentioned before of wingtip vortices or the prop wash causing the chemical to swirl. But it's also just a much more efficient way to move chemical around. So
Right.
the amount of vehicle required to move a kilogram of cargo or a liter of chemical is like roughly speaking a third of the sort of capital
Okay.
cost, if
Okay.
you have wings versus hovering.
Right. And they can stay in the air longer, I imagine.
Yeah, much longer. They can ferry long distances, so you don't have to like
Is
drive
that
the drone around everywhere.
Yeah, I mean that surely must be one of the biggest challenges for you guys, just the sheer weight of the things that you're trying to lift into the air.
Yeah,
How do you get around those?
Yeah, I mean, it's just the like never ending optimization challenge. So the crop spraying aircraft is, it's about 1,400 pounds when it's fully loaded. And
Hmm.
uh, a little bit more than half of that is the liquid that it's carrying.
Yeah.
So it's which is crazy. There are very few airplanes
Yeah.
actually
Yeah.
that
Yeah.
half of the weight of the
Half the
airplane when
weight
it lifts off
is
is its cargo.
cargo. Yeah.
Yep.
Okay. And
So yeah,
how about the because the other vehicle that you have is like cargo delivery.
yeah.
Is that carrying like comparable weights?
It's a little different. So it's the same gross weight, same maximum takeoff weight, because it uses the same wings. It's like many of the systems are shared between the two aircraft. But
Uh-huh.
on the cargo airplane, it has less payload capacity. So it has 400 pounds of weight that it can carry versus a little over 700 for the spray plane. And so
Right.
that delta of 300 pounds is basically moved into the battery of that aircraft. So the
Okay, to
cargo
give it
plane,
more range.
yeah, the cargo plane can fly for like up to 3 hours basically.
Okay.
Whereas the spray plane is actually only designed to do basically two 15-minute flights and then swap its
Right.
batteries.
Okay. Okay.
Yeah.
And then I imagine the cargo plane, like actually protecting the cargo is more of an issue,
Um,
or is that?
yeah. I mean, you need to have like a sort of payload handling system, whereas in the
Uh-huh.
spray plane, you're just pumping the fuselage full of chemical. I would say actually the spray
Yeah.
plane is harder. It turns out
Right.
like making a really lightweight, high performance spray system that you can fly around with, that's actually been quite a substantial engineering challenge.
Okay.
But yeah, they both
Tell,
have
tell me
their
a tell me a little bit about that. Like, what made that so difficult?
So one of the first issues we ran into is you need to pump the liquid out of the tank at a fairly high pressure and a fairly high flow rate. And
Uh-huh.
the best off the shelf option for the electric pump to use weighed 25 pounds, something like that.
Right.
And
Right.
we have 700 pounds of payload to work with. That would have been a bit of a shame to waste 25 of it on that. So we designed
Yeah.
our own, actually like 3D printed high speed centrifugal pump that's driven with a really high performance motor. And so that
Okay.
whole pump assembly, I think, is 2.5 pounds, something like that.
Right.
Uh,
Right. So that's massive reduction.
yeah, yeah. But
Yeah.
it also a lot of challenges. We have to
Yeah.
work on some nice ceramic seals that seal well, and yeah,
Uh-huh.
it's mostly just like sealing, honestly. Many
Yeah.
leaks
Yeah. Yeah.
we've had to deal with.
Yeah. And
Yeah,
I understand that there's maybe over 50 different 3D printed parts on the planes. Like,
yeah. At least I
why
I
was
I think there's more than that.
right? Why was 3D printing like the kind of go-to for a lot of the manufacturing?
Yeah. So just to be clear, the vast majority of the aircraft is made out of carbon fiber.
Yeah.
And then there's quite a bit of CNC machined aluminum parts on the aircraft, like landing gear, rails, and motor
Uh-huh.
mounts, and blah, blah, blah. Um, we use 3D printed parts extensively, basically all SLS nylon, for like many different mounts are done that way. Um,
Right.
Anything that's like a complex geometry um, that particularly is bonded to the carbon fiber,
Uh-huh.
that is like semi load bearing. Um, we wouldn't do something that's like in a high load bearing sort of plausible like fatigue load scenario.
Mm-hmm.
Um,
Mm-hmm.
yeah, and it's been a great solution for that. It bonds nicely to the carbon fiber. Um, you know, we can change it arbitrarily quickly, and don't sink tooling costs or anything like that.
Yeah.
Um, yeah, it's
Have
it's a
you looked at 3D printing for the aluminium parts as well, or?
not so much. There Most of the geometries of our aluminum parts lend themselves just very well to CNC machining. Um,
Okay.
The only place that I'm curious about it is for the impeller of our pump, because that's
Uh-huh.
not it's a complex sort of weird closed geometry.
Yeah.
Um,
Have
but
you
no,
have you used much generative design?
no, that'd be cool. We haven't
Not
we
really,
haven't
no.
dabbled at all in that. Um,
Okay.
yeah,
Because
someday.
I mean, obviously, one of the biggest applications for that is in like weight saving,
Yeah,
for different parts. So that might be
yep,
somewhere you can shave another couple of pounds off, I guess.
yeah, yeah, absolutely.
Okay. Um, and the fact that you don't have a person operating like the vehicle while it's in the air, does that make the whole thing easier in terms of getting it regulated and approved and things like that?
Yeah,
Have you had
yeah.
many hoops to jump through?
We have, but yes, it makes it profoundly easier. Um, so, I mean, one way to think about it is if a if a crop spraying aircraft crashes with a human being on board, there's I don't actually know what the probability of a fatality occurring is, but it's probably 25 to 35%, something like that would be my guess. Um,
That sounds quite low, to be honest.
it is
I
the planes
yeah,
they're designed very well.
right.
So there are a lot of
And
crashes
that's
where
quite heartening. That like, I feel a lot better getting on a plane now, to be honest.
oh well, no, this is an agricultural aircraft. This is if you get in a crop
Yeah,
duster and you crash
yeah,
in the way that crop dusters typically crash, your
uh-huh.
probability of walking out of that aircraft is actually not that low.
Yeah. I mean
If
that,
you're in a
that like I say, that's quite
747,
heartening.
yeah, if you're well,
Uh-huh.
that's why I don't think you should feel too good. If you're in a commercial aircraft and it crashes, your probability of walking out of that is like I think basically zero.
It's like zero. Yeah.
Yeah,
Okay. Okay. All right.
but
Yeah. Next time I go anywhere, I'm going in a crop duster,
yeah,
I
yeah.
think.
No, but don't do that. The probability of the commercial airplane crashing is pretty much
It's
zero
quite
too,
low. Yeah. Yeah.
whereas the
Yeah.
crop duster is a lot
Yeah.
higher. Um, anyways, so yeah, it crashes. Good chance someone dies.
Hmm.
In a crop spraying UAV, if it crashes, it depends on kind of the environment you're flying over, but it's probably like 1 in 10,000th chance that someone is injured or killed.
Yeah.
And
Yeah.
so it's basically it's like multiple orders of magnitude less risky than the thing it's replacing. Um, and so regulators have sort of taken note of that and responded accordingly. And in particular, recently, for example, Brazil has more or less deregulated spray drones,
Okay.
including drones the size of ours. So that's
Okay.
that's huge. I mean, like aviation is probably the most regulated industry on earth. I don't know, maybe like nuclear power is more, but it's incredibly regulated, and
Hmm.
certain markets within the commercial drone space are becoming deregulated.
Okay. Okay. So, like, how safe are they then? Like, how many do crash? Like,
Um, it's hard to give an answer for that. I think most of the commercial drone industry, outside of like DJIs and small stuff,
yeah.
is still at a pretty early stage in development.
Mhm.
Like the vast majority of it is companies that have made a small handful of aircraft that are effectively prototypes.
Mhm.
Um, so where the industry is at right now, like the probability of vehicles being flown crashing is high compared to passenger carrying aviation.
Mhm.
Um, but it's trending in a very positive direction. At least that's what we're seeing on in our development.
And why do the crashes that do happen? Is it to do with the hardware mainly, or is it the software? Like, what's causing the problems?
Yeah, I think a lot of companies crash because of software.
Right.
Um, the software of these aircraft is quite complex, um, and often you make both the software and the hardware fairly redundant, which is good, but adds even more complexity. And so,
Yeah.
especially in the sort of development phase, as you're kind of ironing all the kinks out of that complexity, it can be a little bit unwieldy. For us, historically, we've actually never crashed an aircraft due to a software issue, which is very much a
Right.
testament to the quality of our software team.
Which
We
you build
have had.
yourselves, yeah.
What do you say?
The software is also you take care of that yourselves, yeah.
Yeah, yeah, exactly. We have crashed a couple aircraft due to hardware issues. Um,
Okay.
yep. Um, yeah, that's that.
Mm. Where do you see the kind of future of autonomous flight?
Yeah, like what I'm excited for.
Yeah.
Um, I mean, so we're working on crop spraying aircraft right now. That is a slam dunk use case. Um,
Mm.
I think by the end of this decade, there'll be quite a lot of autonomous crop spraying taking place in Latin America in particular. There's already a lot going on in China. It's basically going China, LATAM, and then US is going to be the last, would be my guess. Um, Cargo is really exciting. It has regulatory challenges that aren't present
Mm.
for crop spraying. In order to do anything useful in the
Is
sort of
that because
cargo,
of where it's operating mainly? So like crop
it's
spraying, obviously it's out in the middle of nowhere quite a lot, isn't it? Away
it
from
is, yeah.
population centers and things like that. Yeah.
So that helps a lot. But the bigger difference is that with cargo, you have to fly the aircraft beyond the visual line of sight of anyone involved in the operation.
Right. Right.
And so then the aircraft needs some way to not hit another airplane.
Yeah,
Um,
okay.
and that's proven to be actually a really hard technical problem to solve, of like adding some sensor system to the vehicle that can detect
Yeah.
other aircraft. It's very surprising that that's been so hard, but it turns out
Yeah.
it has been. Um,
Okay.
yeah,
Okay.
so that's tricky, but there is a lot of progress being made there. There's also a lot of opportunities where the probability of hitting another aircraft is effectively zero.
Yeah.
If you're flying low over the ocean, for example, there
Hmm.
really is no one else using that airspace. So there's already been operators that have been successful with that kind of like concept, or finding specific parts of the world where the air traffic is low and the need
Hmm.
for drone delivery is high. Um, but yeah, it will be a big deal. I think the thing I'm by far the most excited about in the long term is the passenger carrying use case, and that really is why we started Pyka.
Right.
The couple things that we sort of saw when we started the company were small aircraft. Basically, a third of the cost of operating a small airplane is its propulsion system. A third of it is the pilot, and the other
Hmm.
third is like amortization of the vehicle and ticketing and all the landing fees and blah blah blah.
Okay.
And electrification basically brings the cost of the propulsion system to zero.
Right.
It doesn't in the early days. It reduces it by a factor of 5 in the early days, and I think 20 years from now it'll by aviation standards be effectively zero. So that's that's exciting. And then
Yeah.
through automation, we should be able to bring the piloting cost down dramatically.
Uh-huh.
Um, and so the thing that we kind of saw was, if you're able to reduce the cost of small aircraft by, let's say, 50%, it then becomes a very similar cost per mile as driving. Um,
Yeah.
and that's just a really interesting world to envision.
Yeah,
Uh,
yeah.
I think you won't be able to fly across the country in one of these aircraft, but in the UK, you'll be able to traverse
Yeah.
wherever you want. Um,
Yeah.
And yeah, that's really cool. That's like a world that I would love to live in, and given my passion for aviation,
How
like would
how
love.
far are we away from that, do you think?
I think it's going to take kind of
First,
a
one
while.
one in terms of technology, and two in terms of actually being allowed to do it.
So I think that the like key unlock to, I think that the allowed to do it is going to come after the technology. I think the like key technical hurdles in terms of like battery technology, for example, will be cleared sooner than the others. Um,
Yeah.
so from a battery perspective, for example, I think we really want to be at something more like 400 watt hours per kilogram at the cell level, and figure out a way to pack those cells into a battery that has very little sort of extraneous stuff. Um,
Hmm.
I suspect we'll get there in the next 10 years. Like I would be
Right.
surprised, honestly, if we didn't. Um,
Okay.
and that's the only like real technical unlock that has to happen here. Um, and then from a like regulatory side and public perspective, acceptance side of things, I think what needs to happen is like large scale cargo operations taking place for, I don't know, 5 to 10 years, where
Yeah.
that market is mature, is well understood. The safety record of those vehicles is totally clear. And then I think it's a very logical step, that somewhere on Earth people are going to start getting into those cargo aircraft, and
Yeah.
it'll proliferate from there.
Yeah. Okay.
So I
So
don't
it
know,
could, I
probably
mean,
20 years.
it could be
That's my
20,
that's
30
my
years.
my
Yeah.
guess. Yeah.
Okay. Now, how feasible do you think are things like solar powered, like airplanes? Because
Um.
you see those and
Yeah.
they don't
Yeah.
look very realistic.
Yeah. Not really. I mean, they have a use, which is like for a satellite replacement. Um, but for any sort of normal use case like what we're building or passenger carrying, the
Yeah.
the surface area of an airplane is just
It's
way
just
too
not enough.
small. Yeah.
Right.
If
Okay.
we
Okay.
covered our airplanes in solar panels, they would produce, I think, about a tenth of the power required for the aircraft to cruise.
Required. Yeah.
So
Yeah. Okay. All right. I think we'll have to put that on the back burner then. That one.
yeah, yeah,
Yeah. Okay.
probably.
All right. Okay. Yeah. Very, very interesting. Thank you. Thank you very much. If we want to find out a bit more about Pyka and what you guys are up to, where's the best place to have a look?
Yeah. So our website is flypyka.com. So FLYPYKA.com. We're fairly active on LinkedIn as well. So follow our LinkedIn page. We post once a month, something like that, with updates. Um, yeah, those are the best ways.
Okay. All right. Michael Norcia, thank you very much. Thank you.
Great. Thank you.
Whether you're working on your first product or your 10th, you've got the Prototype and See podcast to back you up through your product development journey. Follow, subscribe, and tune in for our next episode. We can't wait to see where your prototype takes you.